Factors and prime numbers. A factor divides exactly into a number, leaving no remainder. So let's say I have the number 26, okay? We divide that number by 13. 26 divided by 13 is 2. Okay, so if we look at the number 26, 13 divides into 26 evenly because we get a whole number here, an integer, there's no remainder. So 13 therefore is a factor of 26. We can divide 26 by 13, get an integer, a whole number, there's no remainder. A prime number has only two factors, 1 and itself. Okay, so if we look at the number 5, for instance, 5 equals 1 times 5. There's no other combination of integers. 2 times 3, for instance, is 6. We'd have to multiply numbers with decimals or fractions together to get the number 5. You can only multiply 1 by 5 to get the value 5 if you're multiplying integers. So therefore 5 is a prime number. If you look at the number 8, for instance, you can multiply 1 by 8 to get 8, of course, but you can also multiply 2, that doesn't look nice, 2 by 4 to get 8. Okay, so 1, 8, 2, 4, these are all factors of the number 8. And so 8 is not a prime number. Also, just of note, 1 is not a prime number. 1 is not prime. That's because you can only multiply 1 by 1, right? And so we have the definition here. A prime number has only two factors, 1 in itself, and the number 1 only has one factor. So let's list the factors of the numbers 1 through 10 and identify which are prime numbers. Okay, well, we just did number 1. That one's pretty straightforward. 1. Number 2 is actually very similar. You can multiply 1 by 2. Okay, so the factors here are 1 and 2. There's nothing else we can do. And actually, that means that 2 is a prime number, and it's the only even prime number. Number 3, let's look at number 3. Factors here, well, 1 times 3. So again, we have a prime number. 1 times 3. Those are the only integers you can multiply together to get the value 3. 4, we're going to have 1 and 4. Okay, 1 times 4, of course, is 4. But also 2 times 2. 2 times 2 gives us 4. So there's 3 factors here, which means that 4 is not prime. 5 we did before. It's 1 and 5. It's prime. 6, there will be a few. We can multiply 1 by 6, and we can also multiply 2 by 3 to get 6. So there's 4 factors here, and 6 is not a prime number. And as we said before, 2 is the only even prime number. So you can pretty much go ahead and eliminate all other even numbers from being prime, because you'll be able to divide them by 2. 7 is 1 and 7. That's prime. 8, again, we already did it. It's 1, 2, 4, and 8. Number 9 is 1 and 9, so that is also prime. And number 10, we can multiply 1 by 10. We can also multiply 2 by 5. And again, we'd know right away because it's even, we can divide it by 2. We just have to figure out what number we multiply by 2 to get 10. So 1, 2, 5, and 10 are all factors of the number 10. Let's list the prime factors of 24. Okay, so first we have to list all the factors, and then we'll identify out of that list which ones are prime. Okay, so I like to start with 1 at one end and then give myself lots of space because I don't know how many values are going to fit in between, and 24 at the end. So obviously 1 times 24 will give me the value 24. And then I just slowly work my way up with more greater values until they meet in the middle, as you'll see by this example. So we can divide 24 by 2. So therefore 2 is a factor, and then I have to figure out, well, 2 times what equals 24? 2 times 12 equals 24. So then we list it there on this side. Next, we look at the number 3. Can we divide 24 by 3 evenly? Yes, we can. And it's 3 times 8. So both 3 and 8 are factors of the number 24. Next, we move up to 4. Can we divide 24 by 4? Yes. And that gives us 6. And here we go. Obviously, we can't divide 24 evenly by 5, so there's no 5 in there. So this is the list of the factors of 24. We start at 1 and 24 and then work our way toward the middle. We just fill it in. Sometimes you'll have a gap in the middle because you're giving yourself a large space and there aren't that many, and that's perfectly fine. So now we need to identify which of these values are prime. Okay, well, we know that 2 is a prime number. We know that 3 is a prime number. And that's it. None of these other values, because this is even, and 1 is not a prime number. So 2 and 3 are prime factors of 24. Which of the following numbers are prime numbers? We're looking at 18, 45, 79, and 90. Okay, so we're going to have to list the factors for these numbers to figure out whether they're prime or not. So let's do this. 18. Well, actually, we can skip ahead and get rid of this one right away because it's even, and as we said, of course, there's going to be a bunch of different factors here, or at least it will be divisible by 2. So you'll have 1, 18, and 2, and something else. And of course, there could be more. So for instance, 1 and 18, 2 and 9, 3 and 6, so there do happen to be more. But of course, we can eliminate it right away because it's even and greater than 2. So let's look at 45 then. This one will take some working out. So we'll do 1 here, 45 here, and we'll work our way up. So can we divide this by 2? No, because it's odd. Can we divide it by 3? Yes, we can. So 3 times 15 gives us 45. Can we divide it by 4? No. By 5? Yes, 5 and 9, and that will be it. 6, 7, 8, those don't work. So because there's multiple factors, 45 is not prime. 45 is also not prime. So we've eliminated 2 of them. Let's do 79. So we'll write 1 and 79, give ourselves some space in the middle to figure this out. Can we divide this by 2 evenly? We cannot. Can we divide it by 3 evenly? No, that doesn't work. 4, no. 5, no. 6. Can we divide 79 by 6 evenly? 6 times 12 is 78. 6 times 12 is 72, sorry. 6 times 13 is 78. 6, no. 7, no. 8, no. 9, we can't. So there are no other factors of 79. So you see I just did that all verbally, but I worked my way through, up through 2 and 3 and 4 and 5. I checked all these values to see if I could divide 79 by them. I could not. And so therefore 79 is indeed, yes, a prime number. The only factors are 1 and 79. 90, we could write them all out. There's going to be quite a few, but already it's even, it's greater than 2, so immediately, no, this is not a prime number. So which of these following numbers are prime? We found 1, and it is 79. All the rest, 18, 45, and 90, have multiple factors, so they are not prime numbers.